So in this lesson, we're going to apply our knowledge of equivalent ratios, also known as proportions, so that you can solve real-world problems involving proportional relationships. You'll know you've got it when you scored 100% on the assignment over this lesson. So we're going to start off with two vocabulary words for this lesson that you need to understand. And one is equivalent ratios. Another word we will use for these equivalent ratios are called proportions. And the other vocabulary word is a scale factor. Ratios that are equivalent can be simplified to the same values. Those are equivalent fractions. If you can simplify them to the same values, they're called equivalent fractions or proportions. So here are some examples. We have 4 to 5, 8 to 10, 12 to 15. You can write those with those colons, but remember those are also fractions. So 4 to 5, 8 to 10, and 12 to 15. When you look at these fractions, they are all equivalent. Because when we simplify the fractions, they all simplify to 4/5. 8 and 10 have a common factor of 2. So when you divide 8 by 2 and 10 by 2, you get 4/5. 12 and 15 have a common factor of 3. So when you divide 12 by 3 and 15 by 3, you also get 4/5. So when you put your fractions that you're comparing to one another into lowest terms, if you get the same simplified fraction, then they are equivalent fractions. Another way to think about it is 4/5. 4 to 5 is the decimal 0.8. That's one of our memorized ones. 8/10 is also 0.8, a memorized one. If you didn't have 12/15 memorized, which most of us probably don't, but you recognize it as 4 to 5, or you divide 12 divided by 15, you will get the decimal 0.8. And that's another way to simplify fractions, is to convert them to decimals by doing the division. When you do the division, they all come out the same value. So that is another way to check for equivalent ratios. Here's another example: 1/6, 2/12, and 3/18. 1/6 is in simplest form. We can divide 2 by itself and 12 by 2. That's a common factor of 2 and 12 to put it into lowest terms, and you will get 1/6. 3/18 has a common factor of 3, so when we put 3/18 into simplest form or lowest terms, when we simplify it, we also get 1/6. You could also convert 1/6 to a decimal by dividing 1 by 6. And when you divide 1 by 6, you will get a decimal. It's a repeater, but you will get the decimal for 1/6 is 0.16 repeating. It's about 16 to 17%, if you think about it that way. When you divide 2 by 12, you will also get 0.16 as a decimal, repeating. And finally, if you divide 3 by 18, you will get the same value when you divide it, and it's 0.16 repeating. So ratios that are equivalent can be simplified to the same values, just like an equivalent fraction. And the next term you're going to hear me use in this lesson is a scale factor. A scale factor, here we go, it's the factor or the multiplier. In which both numbers in a ratio is a fraction, are multiplied by to form an equivalent ratio. So if we're looking at this setup right here, we're saying, hey, I want to change 5 to 20 and 2 to 8. So what I could do is I can multiply 2 times 4. I can multiply 5 times 4. And that'll create my 8 over 20. So my multiplier for that would have been 4. The other way we could look at it is we could say, hey, a factor. I could divide 8 by 4, divide 20 by 4, and I could work that number backwards. So I'm either scaling it up 4 times bigger, or I'm taking 1/4 of it, dividing it by 4 to go into lowest terms, creating equivalent fractions using multiplication, or creating equivalent fractions using division. So that is what we mean by a scale factor. What is the number right here that we are using to scale our fraction up or scale our fraction down? The directions are asking us here to create 2 ratios that are equivalent to the ratio we're given. So when you're looking at this ratio, it's 3 to 11. We can write that as a fraction. I think a lot of times writing it as a fraction will help us to see what we need to do to create those equivalent fractions. So 3/11 is in simplest form. So in order to create an equivalent fraction, I need to scale that. It's all scaled down. I need to scale it up. To scale a fraction up, we're going to choose a number to multiply by. Since we aren't told what we want that denominator or numerator to be, we have our choice on what we want to scale it up by. And so I'm going to first scale up my first one. I'm just going to scale it up by 2. Create an equivalent fraction, and I'm going to use a 2 multiplier. And I get 6 over 22. So that's 1. I could also then take the 3/11ths, and I could scale it up by 10 if I want. Again, you can pick whatever value you want to scale it. These are just 2 of infinitely many choices we can make. What you do to the bottom, you have to do to the top. We learned that a while back when we were creating equivalent fractions. So that would be 3 times 10 is 30, and 11 times 10 is 110. And those are equivalent fractions. Actually, 6/22 is also equivalent to 30 over 110. These are all equivalent. Here's our next one, 18 to 12. So we're going to set up our fraction so we can see what we're doing. And I'm looking at this one saying, hey, I can scale this one down because they have a common factor. I can see a common factor of 2. They also have a common factor of 3. And they have a common factor of 6. I can pick any one of those to scale it down. I'm going to pick 3 because they didn't tell us how we had to do it. They didn't say put it in lowest terms. They said just create an equivalent. So I'm going to divide the top and bottom both by 3 to create that equivalent fraction. And I get 6 over 4. It's not in lowest terms, but it is scaled down. It's equivalent to 18 to 12. And we have to do another one. I can scale it down again, or I can scale it up by multiplying by any number I want. I am going to scale this up. I am going to multiply the top and the bottom by 2. $18 times 2 is 36, and 12 times 2 is 24. So I've created an equivalent fraction too. 6/4 is equivalent to 18/12, and 36/24 is equivalent to 18/12, and these two are also equivalent. These are my multipliers when I'm multiplying to generate my equivalent fractions, or I have factors here that I'm using to generate my equivalent fractions, to scale them up when I multiply and scale them down when I divide. Okay, 6 to 10. When I look at this one, I know I can either scale it up, but I can even scale it down because this is not in lowest terms. It has a common factor of 2. So I'm going to first opt to scale it down for my equivalent fraction. Putting it in simplest form is what's going to happen here, because 2 is the greatest common factor of 6 and 10. And we get 3/5. Then, and so if you think about it again, the value of 6/10 is 0.6. That's a memorized one that we're supposed to know in our heads. And 3/5 is also memorized. We're supposed to know that in our heads. They're both 60%. They have the same value as a decimal, and they are equivalent fractions, equivalent ratios, because they have they can be scaled down to 3/5 from 6/10, or scaled up. If I double 3 and double 5, I can scale it up to 6/10. So that's one equivalent fraction. Now I'm going to scale it up. I'm going to multiply. I'm going to multiply by 8. I can pick any number I want to scale it up to create that equivalent fraction, as long as I do it to the top and the bottom. And I get 48 out of 80. And those are 2 equivalent fractions for each of the given ratios. 2 equivalent ratios when they gave us the starter ratios. So we need to decide if 2/5 and 8/20 are equal. And there's a few ways to do this. So first way I'm going to do it is I'm going to try to determine if they're equivalent, and then if they are, I'm going to figure out what multiplier or scale factor I use. So looking at 2/5 and 8/20, to determine if they're equivalent, I'm just going to try to put my fractions into lowest terms. So I check this one. It's already in lowest terms. 2/5 is all set. Now I'm going to look at the 8/20. If 8/20 was in lowest terms, I would be able to tell that these were not equal. But 8/20 is not in lowest terms. So I have to do some work to see if they're equal or not. So I'm just going to write 8/20 off to the side, and I'm going to reduce it. 8 can be reduced by, and 20 have a common factor of 4. That's the GCF for an 8 and a 20. Your basic fact knowledge skills come in handy here. You should recognize that 4 goes into 8 and 4 goes into 20. So I'm going to divide both by 4. And when I do that, I'm going to get 2/5. So when I put this one into lowest terms, I get 2/5. This is already in lowest terms, and it's 2/5. So they are equivalent. So that's step number 1. Determine if they are equivalent. And these are equivalent because I used their lowest terms, and their values came out the same when I simplified them. So the next step, once we decide if they are equivalent or not, is to determine the multiplier or the scale factor. So to determine that multiplier or scale factor, I'm just going to write these two next to each other with the equal sign in between. And I'm going to look to see, hey, if I want to multiply something to 2 to get 8, what would that be? Well, it would be 4. And that's what I would also multiply to the bottom to get 20, which is 4. What we do to the top and the bottom, they have to match. I'm going to write that in a different color so we can see that 4 better. So that's what we need as our multiplier to go from one fraction to another. So the scale factor, because they're equivalent, there will be a scale factor, and it is 4. So I've answered both parts to that question. Are they equivalent? And if they are, you need to find that scale factor. What are we going to do to one fraction in order to create to the other? And it's a multiplier or a factor. Some of you may have thought going the other way. What can I divide 20 by to get 5? And what can I divide 8 by to get 4? And the answer is 4. So even if we go the other way, we're finding the factor versus the multiplier, but they're the same number. Okay, this one right here, 12 over 4, 6 over 3. We need to know if they're equivalent. So what I'm going to do is I'm going to put them into lowest terms. 12 can be, for putting 12 into lowest terms, we can divide, and 12 fourths into lowest terms, we can divide 12 by 4. and 4 by 4. They have a GCF of 4. Greatest common factor is 4. So we end up with the fraction 12 divided by 4 is 3. 4 divided by 4 is 1. So 12/4 is 3 to 1. You probably, hopefully knew just by looking at it from your basic fact knowledge. And then we're going to come over here. 6 divided by 3 is 2, and 3 divided by 3 is 1. So the ratio that's equivalent to 6/3 in lowest terms is 2 to 1. So this one's 3 to 1, this one's 2 to 1. They are not equivalent. Because they are not equivalent, they will not have a scale factor. Okay, and then finally, our third example. First thing to do is to look at both fractions and try maybe to get them just into lowest terms. So we have the 8/6. They're both even. So I know they're not in lowest terms. I can divide 2 out of both. And 2 is the GCF for an 8 and a 6. So I'll be done once I divide that 2 out. And when we divide 8 by 2, we get 4. When we divide 6 by 2, we get 3. So this reduces to 4/3. Now we're going to do the same for 20 over 15. But I need to find the GCF of a 20 and a 15. Well, this ends in 0 and this ends in 5, so I know 5 is a factor, and it happens to be the greatest common factor. So I divide 5 out of the top and the bottom, and when I do that, I also get 4 to 3. Okay, so they are equivalent because their lowest term value are the same. So I'm going to say they're equivalent. Since I'm saying they're equivalent, there's a second part. You have to determine the scale factor. So to determine the scale factor, let's just set up the equivalent fractions, also known as a proportion. Two fractions that form an equation are proportions. So we're going to write it as 8. I'll just actually change the and sign to an equal sign, because they are equal. We just proved it with the 4/3 here and here. So we have to figure out what number we would multiply to 8 to get to 20, and what number we would multiply to 6 to get to a 15. So in other words, 15 divided by 6 is what? And 20 divided by 8 is what? So to figure out this number that we're multiplying or dividing by, we just need to do a little bit of computation. Well, it's 2.5. It's a decimal. 6 times 2.5 is 15, and 8 times 2.5 is 20. 8 times 2 is 16. Half of 8 is 4. 16 and 4 is 20. 6 times 2 is 12. Half of 6 is 3. 12 plus 3 is 15. So our scale factor is 2.5. That's the number that we either have to multiply 8 and 6 by to get 20 and 15, or it's the number you have to divide 20 by to get 8 and 15 by to get 6. Okay, in this next problem, we have Audrey and Megan are decorating for a birthday party. Audrey hangs 4 streamers in the same amount of time that it takes Megan to hang 6 streamers. If Audrey hangs 12 streamers, then how many streamers can Megan hang? Determine the scale factor. So I am given a ratio to start with. I'm given the ratio of 4 to 6. Audrey's 4 to Megan's 6. So they're hanging streamers, and apparently Megan hangs them a little faster than Audrey because she gets 2 extra streamers in here. So looking at this diagram, this is called a tape diagram. We use a diagram to represent the 4 streamers that Audrey is hanging. And then we use this to represent the 6 streamers. So that's our original ratio. It's 4 to 6. So I'm going to express it as a fraction. So we want to figure out if Audrey is able to hang 12 streamers, then how many streamers can Megan hang in that same amount of time? Well, it's going to be more than 12 because Megan hangs hers a little faster. So if we're looking at this, initially this represents 4. However, we're going to change it up a little bit. We're going to say now this is our 12 streamers, represents 12 now. And we want to know how many streamers are going to be on this diagram if Audrey can do 12. Put that in green, just color code it. So each piece here is going to need to represent 3 streamers in order to end up with a 12 total. So each piece here also then represents 3 streamers, and we have 6 pieces this time. So we end up with 18 streamers because 3 times 6 is 18. So we end up with an 18 here. Again, it's figuring out how we go to create that equivalent fraction from a 4 to a 12. We would multiply by 3. What you do to the top, you're going to do to the bottom to keep that ratio equivalent. 6 times 3 is 18. So that's our equivalent fraction, and now it's asking for the scale factor. Remember, the scale factor is either a multiplier or a factor that you use to generate your new equivalent fraction. And right here, the scale factor is 3. We had to triple each number to get and build our fraction up to the equivalent fraction of 12 to 18. So the scale factor is 3. Okay, so here's another equivalent fraction problem, equivalent ratios. Sally's summer punch recipe is a combination of lemonade and fruit punch. Sally uses 3 cups of lemonade for every 4 cups of fruit punch. So she's mixing the two together to get a concoction for a 4th of July party. In order to make a batch for the 4th of July party, Sally uses 21 cups of lemonade. Must be a lot of people coming. So just using the 3 cups and the 4 cups is going to run out too quick. So she's scaling up her fruit punch, her summer punch. So she's using 21 cups of lemonade, and she needs to figure out how many cups of fruit punch to use to get the right recipe, to get the right flavor. So we're going to start here, just circling some information. 3 cups of lemonade to every 4 cups of fruit punch. So I'm just going to color code that. And she knows she's going to use 21 cups of lemonade. And we want to figure out, to make that summer punch recipe, she needs to know how much fruit punch to put in so it tastes right with her lemonade mix. So we're going to do what we call a double line diagram. I have 2 number lines here. The first number line is our cups of lemonade, and the second number line is our fruit punch. So what I'm going to do is I'm going to start to just mark off our ratio using this double line diagram. So to start with, let's just number this 0 cups of lemonade. Whoops, helps if I'm using the pencil tool. 0 cups of lemonade. And this is 3 cups of lemonade. And then 0 cups of fruit punch. And my first tick mark is 4 cups of fruit punch, because the ratio is 3 to 4. So I'm going to mark my 3, mark my 4. So if I'm making just one batch, it's 3 cups to 4 cups. But if I decide to make 2 batches, then I need to up my recipe. And if I make 2 batches, let's draw a line through, I will need 6 cups of lemonade, because I'm going to double my 3 cups. I need 6 cups of lemonade to 8 cups of fruit punch. I have to double both. Equivalent fractions. These are equivalent, 3/4 and 6/8. Okay, if I want to up the recipe again, and I want to make 3 batches, I'll need to triple my recipe. 3 times 3 is 9. And 3 times 4 is 12. So I have 9 to 12. That's equivalent to 3 to 4. So what I'm doing is I'm scaling my recipe up. And whatever I am scaling it by, I multiply the top and the bottom. So I'm really just skippy counting here by 3s, and I'm skippy counting here by 4s. And if I do that, the recipe will taste the same, even though I'm upping the number of cups, because I'm upping the both by the same scale factor. So it's going to taste good. It's going to taste right, because the recipe numbers are changing, but they're changing by the same scale factor. So if I decide to do 4, quadruple it, I had 3 to start. My recipe says 3 to 4, so if I decide to make 4 batches, I need 12 cups of lemonade. And if it was 4 to 1 batch, I need 16 cups of fruit punch. And then I'm going to make 5 batches. If it's 3 to 4, it becomes 15 to 20. And then finally, if I'm trying to make 6 batches, well, not finally, but I'm trying to make 6 batches, I'm now at 18 cups of lemonade. To 24 cups of fruit punch. And then if I go a 7th batch, I'm going to have 21 cups of the lemonade to 28 cups of the fruit punch. And that's what they were looking for. 21 right here. Said, hey, if we use 21 cups of lemonade and we want this to taste like the summer punch recipe, we need to use 28 cups of the fruit punch. So your answer is 28. Okay, you can use a double line diagram, or you can also, you're advanced, you can also try to set up an equivalent fraction where you see the lemonade on top, the fruit punch on the bottom, 3 to 4, and we want 21 cups of lemonade is what we're going to ultimately need to get enough punch. And what do we scale that up by? To get from 3 to 21, we have to scale it up 7 times. We have to multiply 1 batch by 7. So that's what we'd have to do to the bottom, and you get your 28 equivalent ratios. Now the punch is going to taste right because we scaled it up by the same scale factor. The scale factor was 7. So this says, use the pattern below to determine how many gray squares there will be if we have 15 white squares. 15 white squares. So looking at the diagram, the ratio they're giving us in this diagram, the pattern we need to stick with is that we have 3 white to every 4 gray squares. So the fraction would be 3 over 4. It might be easier to view it this way. It doesn't matter though. It'll all work out the same no matter how you express that ratio. So we're going to make a diagram. We're going to take this diagram that they started us with. We're going to use that pattern until we get 15 white squares. So I'm going to come up, grab my shape tool real quick. I'm going to make sure my fill is not on. And I'm going to start making some squares, some white squares using the pattern. So when I draw these 3 white squares in, I have 6 white squares. I'm going to just draw 3 in each row that I create, just like there's 3 in the first row. Now I have 9. So you can see I'm scaling, I'm adding 3 every time I make a row. and I have 12, 13, 14, I have 15 white squares. It took me the row they gave me plus 4 more rows, 5 rows altogether to get those 15 white squares. Now I'm going to create those gray squares. Each row has 4. I need 5 rows, so I'm going to make 4 gray squares in each row. So I have my diagram drawn. How many gray squares will I get if I have 15 white squares using the same pattern? Well, we have 5 rows with 3 white in each for a total of 15. 15 white. And that's what I'm looking to get over here. I'm looking to have 15 white squares. And I do. It took 5 rows to get there. Now, I have 5 rows with 4 gray squares in each row, following the same pattern. That gives me 20. So I end up with 20 gray squares. So we had to scale this diagram from 3 over 4. We had to scale each of them up by 5 to get that 20. And that's what they were looking for. How many gray squares if we use the pattern? 20 gray squares. If you have 15, you're required to have 20 gray based on the pattern. It doesn't ask for the scale factor, but if you were looking for it, it would have been 5. We had to scale up both numbers by 5 to create the equivalent ratio, and that allowed us to get to that new fraction. All right, this next problem says use your understanding of equivalent ratios to figure out the answer to this problem. Mrs. Maloney earns 2 hours of paid vacation for every 9 days she works. So right there, we're comparing two things. We're comparing hours to paid vacation. So those are the two things we're comparing. And she earns 2 hours for every 9 days she works. So I'm going to use H to represent her earned vacation time, hours earned, and I'm going to represent days with the number D's, days worked. And we're going to write the ratio that we're given, which is 2 hours earned if she works 9 days. So now what we're trying to figure out is how many hours of paid vacation is she going to earn if she works 81 days. So we don't know how many hours she's earned. We need to figure it out if she works 81 days. So looking at this, I didn't set it up in a fraction form, but we could definitely do that. We could say hours over days, 2 hours earned after 9 days of work, and how many hours is she going to earn after 81 days of working. So either way you set it up, you should be able to see this relationship now. We're scaling up. We have to figure out how to get from a 9 to an 8. Remember, it's always a multiplication or a division, and if it's going up, we're multiplying. And your basic fact knowledge tells you multiply by 9 to get 81, so we're going to multiply by 9 to get 18. And you can see that here as well. To get from a 9 to an 81, you would just multiply by 9, and you would get that 18. So if she works 81 hours, she will have 81 days. I keep saying that wrong. Hopefully I didn't say it wrong earlier. 81 days. She will have 9 hours of vacation time. So that's an equivalent ratio. We use equivalent ratios to scale up or scale down. In this case, we scaled up. Okay, we're going to use our understanding of equivalent ratios to answer the questions below. We have a wrapping paper fundraiser, and it sells rolls of gold and red wrapping paper. So I'll circle that in that color, and I'll use a goldish color for here, gold and red. The ratio of gold rolls to red rolls, so we have gold to red, they're giving us that ratio wording, tell you we're making a comparison here, is 5 to 8. So I'm going to rewrite that down here. 8 is the red, 5 is the gold. We got to get it in the right order. Order matters for ratios. In our previous unit, we studied that. So it's 5 gold to 8 red. If the school sells 78 rolls, that's a new number. The school sells 78 rolls. They didn't distinguish color, so that's a total number of rolls. How many were gold? So we need to figure out how many were gold. So sometimes they don't give you all the numbers straight up. Sometimes you need to piece things together and think. So the ratio we're given here would be total 78 to gold. So I'm going to say, hey, I don't know. I'm trying to figure out how many gold, but I know they sold 78 all together. That was the total. So I'm using the notation down here just to shorten up the words. This is what I know. Well, this is a part to part. It's both parts that I'm given. I'm given the 2 types of wrapping paper colors that they're selling, and I need to use this information to help me get a fraction I can use to solve for gold. So if they had 5 rolls of gold to 8 rolls of red, they had a total of 13 here. So the total here is 13. 13 rolls of wrapping paper. So I'm going to come over here and I'm going to set up a new ratio. I'm going to set up 13 as my total to gold, which I don't know. Oh, sorry, I do know 5. So now I have 2 ratios that I can use here and set them up as equivalent ratios to find G, the missing number of gold. So it's G and 5. I'm going to set them up as fractions. We could have done that from the get-go too. And then it's 78 to 13. So now I need to figure out how to scale this up to find out if we start off 5 were sold gold to every 13 rolls sold. 5 of them were gold. How do I get from a 13 to a 78? If I go from 13 to 78, I had to multiply by what? Well, how many times does 13 go into 78? If you don't know, you can do a little long division. And I believe it's 6. 3 times 6 is 18, carry the 1. 1 times 6 is 6, plus 1 is 7. Yep, 6 times. So I'd have to multiply that by 6. Every time I have 5 gold, there were 13 altogether. So I have to now scale that up by 6. And I get 30. So sometimes our ratios give us all the parts we need to figure out the answer, but we have to piece that puzzle together. So how many gold were sold? If there were 78, then 30 of them were gold. There are a total of 30 puzzle pieces. That's a total amount, 30 puzzle pieces. 3 out of 5 are red. So 3 out of every 5 pieces in our bunch are red. The remaining are black. How many puzzle pieces are black? There are a total of 30 puzzle pieces. 3 out of every 5 are red. The remaining are black. How many puzzle pieces are black? There are definitely a few ways to approach this problem, but I'm just going to start with simply the ratio they gave me, which was 3 to 5 are red. 3 out of 5 are red. So I'm going to write that ratio. 3 out of 5. 3 are red and 5 is total. 3 puzzle pieces to every 5 puzzle pieces are red. And there are 30 puzzle pieces. So I'm going to create a new ratio that says, hey, 3 to every 5, I need 30 altogether. So how many are going to be red? So I'm going to focus in right now on finding the red pieces. Again, there's other ways to approach this problem. We're just going to use the 3 to 5 and the 30. To scale up my 5 total to 30 total, I need to multiply by 6. What I do to the bottom, I do to the top. I need to multiply by 6, and I get 18. That means I have 18 red pieces. Okay, and there are 30 altogether. So to find the black pieces, I would simply take my total 30 and subtract the red, which is 18, and I would get 12. That's one way to find how many pieces are black. There are 12. Another approach, just to look at it differently, if we know every 3 to 5 are red, that means that 2 to 5 are black. 2 to 5 are black. So I could set up a ratio here where I say, hey, I need 30 altogether, scale that up to 30, multiply by 6, multiply by my scale factor 6, and I could get 12 that way. Where I subtract 5, take away 3 is 2, and that tells me 3 to 5 are red, therefore 2 to 5 are black, and then I can scale it up to 30 from there. Okay, I'm going to have you try to answer this question on your own, and when you're done, I want you to turn the video back on to see if you answered it correctly. Jamal says that 18 to 12 and 3 to 4 are not equivalent fractions. Marge says they are equivalent ratios. Who is correct? And justify your solution. So I want you to think about race, restate, answer, cite, and explain. Use math terms to help make sure you're clear in your explanation. If you're using it, they, them, you need to try to replace those with math terms that we've had today. Okay, so pause the video, and then when you get your answer, turn it back on to see if you have it correct. Not just the yes or no, who's correct. Also, justify why you selected them. How come you know that student is correct? Hey, you should have said that Jamal is correct. That 18 to 12 and 3 to 4 are not equivalent fractions. In order for fractions to be equivalent, this is your justify, they must have the same simplified value. So when you're looking at these right here, this supports your justify. You show that the fraction 18/12 in lowest terms is 3/2, or 1.5 is a decimal, and 3/4 is already in lowest terms, and 3/2 does not match 3/4. They should come out exactly the same in lowest terms. Also, 3/4 is 0.75 as a decimal, and 1.5, the value of this fraction, 3/2, does not equal the value of 3/4. They're different decimal values. So that is how come Jamal is correct and Margie is incorrect. So you can use equivalent ratios to solve problems, and you can use patterns. You can use diagrams, tape diagrams, double line diagrams to help you map out what you're doing. Or you can just set up the equivalent fractions and find the scale factors that are appropriate for creating your new fractions. We scale up and we scale down. When we scale up, we multiply by a number, same number top and bottom. When we scale down, we divide by the same number on the top and bottom. So that concludes today's lesson. Good luck on your assignment.